The Milky Way is a tremendous structure in space containing billions of stars and trillions of planets. In their turn, these objects are surrounded by gigantic clouds of interstellar dust and scorching hot gas streams. All these components make up the bizarre and fascinating picture called galaxy. And today, we invite you on an exciting journey across it. We'll start out near the star system closest to our Sun, Alpha Centauri. Whizzing on hundreds of times faster than light, we will fly around some of the most remarkable stars closest to us and then briefly stop near an unusual planet whose surface is completely submerged by a perpetually boiling ocean. Placing our lives in peril, we will nevertheless approach an unstable pulsating giant enjoying its last millennia of life, and then pay a visit to the most extreme and forbidding exoplanets. Straight after that, it will be time for the most mysterious and dangerous objects in the Milky Way, black holes. And then we will pierce the galaxy in a swift flight, from the bright center richly illumined by the stars to its very edge, concealing mysterious dark matter. Let's get ready, and we begin. The Earth has been emitting structured radio signals into space for around 100 years now. The radio noise from the Earth reached dozens of other stellar systems long ago, including Arcturus, lying 37 light-years away from us, and Aldebaran, which is roughly 65 light-years away. Besides, our radio signals may be heard on the surfaces of a great number of potentially habitable exoplanets, like Ross 128b or Gliese 667cc. Still, the triple stellar system of Alpha Centauri remains the closest neighbor of the Sun, which automatically makes it the first obvious candidate for the destination of the first ever interstellar flight. Alpha Centauri is known to be a multiple stellar system made up of 3 components. 2 of the larger ones are relatively close to each other. Seen with the naked eye, they appear to be a single source of light. The 2 components follow a slightly elongated orbit around the common mass center, which takes around 80 years to complete. The maximal distance between the stars may reach 35 astronomical units, with the minimal distance reaching 11.2 astronomical units. As for the distance between these objects and the Sun, it is reportedly 4.36 light-years. The most massive, the largest and the brightest component in the system is dubbed Alpha Centauri A. This is a main sequence star with a mass of about 108% that of the Sun. Its radius is reportedly 1.22 times that of our Sun. Even though the surface temperature and the spectral class of Alpha Centauri A are close to those of our star, it emits 1.5 times as much energy. There are no confirmed exoplanets in the environs of this star. However, while the star was being observed in the infrared in 2021, some evidence was found of there being a planet-like object close by. According to preliminary estimates, its mass may be anything from 9 to 35 Earth masses, and its radius may measure 3.3 to 7 times that of our planet. 1.1 astronomical units away from its parent star, the hypothetical celestial body completes a full orbit around it within roughly a year. Additional observations are called for to verify the data, which can be done with the help of either the James Webb Telescope or else Earth-based observatories. The second component of the system is called Alpha Centauri b, or Ptolemy, and it also falls into the class of main sequence stars. However, its mass is 10% less than that of the Sun, and its radius measures only 86% or so that of the Sun. Ptolemy is also slightly cooler than our star. Its surface temperature is reportedly 5,260 Kelvin, or slightly lower than 5,000 degrees Celsius. With these factors combined, the celestial object has an orange hue and its luminosity is on average twice as low as that of our Sun. Incidentally, Alpha Centauri b emits a lot more energy in the X-ray range compared with other objects of its class. Besides, the star is peculiar for its temper, and there are bright flares and ejections to be seen on its surface. No confirmed exoplanets have been detected near this star either. In 2012, a group of astronomers from the Geneva Observatory put forward a suggestion that there was a planet very close to it, whose orbital period was around 12 days and whose radius measured slightly less than that of the Earth. The suggestion was made based on 4 years of observation of the star's proper motion. However, 3 years later, a mathematical error was detected to have been made in the course of data processing, and so the idea of there being a planet was found to be erroneous.